Hi everyone, I am Gautam, physics faculty. Now I am going to discuss a topic, method of mixtures. So in this topic what I want to say is, I selected two bodies. Suppose one body temperature is T1 degree centigrade and other body temperature is T2 degree centigrade. Suppose let T1 is greater than T2, T1 is greater than T2. Now what I am telling is, if T1 is greater than T2, obviously I can understand that is T1 temperature body is hot body and T2 temperature body is called as cold body. Now these two bodies, suppose if I keep in contact, what will happen here? So we know the one phenomena that heat always flows from hot body to cold body. Heat energy always flows from where to where? Hot body to cold body. So when the heat starts flowing from hot body to cold body, after some time the two bodies will acquire same temperature. These two bodies, let me write this name as A and for this body as B. So A, B, the two bodies are kept in contact. Now when the two bodies are kept in contact, no doubt heat flows from where to where? Hot body to cold body, until both get same temperature. That means both are now acquiring the temperature. Let me call it as T. T is the resultant temperature. So here they are getting the T temperature, both the bodies. We also call this condition as thermal equilibrium. So this is a general phenomena already we came to know when we started the topic of heat. In my previous videos I informed you. That is, here two bodies are there. What happened? First I have taken one body A and this is the body A and this is the body A. There are different temperatures, and when they kept in contact, the two bodies of different temperatures in contact, always we know that heat flows from hot body to cold body. Here we treated this one temperature T1 is greater than T2. So the first body which is having the T1 temperature A, I treated it as hot body, and B I treat as cold body. Now what happened? Heat started flowing from hot to cold. Automatically when heat is going from hot to cold, after some time both the bodies will acquire same temperature T, and when they acquire the same temperature we call it as thermal equilibrium. Okay, fine. So what is happened in this process means, if you observe, this hot body loses heat energy. Hot body loses some heat energy, and how much energy it loses, that energy is gained by cold body. So the heat energy lost by hot body is equal to heat energy gained by cold body. So here cold body is gaining heat. Whatever the heat lost by the hot body, the same heat energy is gained by cold body. So heat lost by hot body is equal to heat gained by cold body. So because of that, what happened? Both the bodies they got the same temperature, and we are calling them as they are in the condition of thermal equilibrium. Fine. Let us observe the phenomena now. So what we have given information here is that we told just now that heat lost by, that means when the two bodies are mixed. So what happened here? Heat lost by hot body is equal to heat gained by cold body. So we are very much happy with this phenomena, because already we know this very clearly, that how much heat is lost by hot body, that heat is gained by the cold body. There is no loss of heat. to the surroundings or any other places. So whatever the heat lost by hot body, everything is gained by cold body. Fine. So this phenomena, what we are calling it as method of mixtures. This is the principle of method of mixture. What is the principle involved in this topic of method of mixtures? Means when two or more bodies of different temperature kept in contact, whatever the heat lost by hot body, the same energy is gained by cold body. So heat lost by hot body is equal to heat gained by cold body. That we are calling it as the principle of method of mixtures. Fine. Now what we'll do means, we'll take the two substances as usual. First, the two substances name, as I told previously, the same thing I'll take here. This is A and B, and here this body is having temperature T1 and this body is temperature T2. So I will take the same condition here. T1 is greater than T2. If I mention T1 is greater than T2, automatically you will understand that body A is hot body and B is cold body. B is cold body. Because just I have taken T1 greater than T2. There is no rule that we have to take T1 greater than T2 only. We can take T2 greater than T1 also. For here example I considered A is hot body, B is cold body. Hot body means it has more temperature than cold body. So I have wrote it as T1 greater than T2. I hope you are clear with this information now. Let us proceed further. What is the phenomena happening here? So now what I am doing means these two bodies are kept in contact. Let me take the mass of this body A is M1, specific heat is S1, and mass of the body B is M2 and specific heat is S2. Now these two bodies are kept in contact. These two bodies now kept in contact. So the mass is M1 S1 T1, mass M1 specific heat S1 temperature T1. For the other body, this is a A and this is a B and this is a M2, S2 and T2, and we told this is a hot body and this is a cold body, and like that we gave the information here. Anyhow, so what happened when they kept like that? Automatically heat flows from where to where? We know, hot body to cold body, until they acquired same temperature. Until they acquired same temperature. Let me take the same temperature they acquired is called as resultant temperature. Resultant temperature. Now what will happen means the first body decreases its temperature from T1 to T. So it loses, that means the temperature, it decreases, temperature decreases from T1 to T, and cold body temperature increases from T2 to T. So here what happened? If you observe, this is a hot body, right? From hot body to cold body, what I told here, hot body to cold body temperature, hot body temperature decreases. Hot body temperature decreases. Cold body temperature increases. Cold body temperature increases. So here hot body temperature decreases from initially T1 to T, and cold body temperature increases from T2 to T. That is the phenomena what happened here. Fine, we will go back to our formula here, method of mixtures. So in the method of mixtures, already we told that heat lost by hot body is equal to heat gained by cold body. So heat lost by hot body and cold body. How much heat is lost by hot body? That is gained by heat lost by hot body is equal to heat gained by cold body. So fine, what is the formula for heat? What is the formula for heat? Remember the example I selected here. In this example, there is no change of state. There is no change of state. That means state is not changing. In the same state, the temperatures has been changed. So here I consider the example where there is no change of state and only temperature changes. No change of state and temperature changes. That means what should the formula have to take here now? From this information, what formula I have to take? Two things I noticed. There is no change of state. There is no change of state and temperature changes. So from this information I can easily understand there is no change of state and temperature changes means heat energy formula I can write ms delta theta. This is the formula of heat. Q is called as heat energy, M is mass. Here Q is what? Heat energy, M is mass, and S is specific heat, delta theta is temperature difference. High temperature minus low temperature. So here no change, that means there is no change of state. Here the two bodies remains, A and B remains in the same state. Just their temperature has been changed. From here T1 to T it is decreased, T2 to T it is increased. Only change in temperature. So my formula is now Q equal to ms delta theta. Already we came to know there are two formulae actually we have. One is Q equal to ms delta theta, other one is Q equal to ml, latent heat, that is during change of state. But now we are discussing about no change of state, temperature changes, means we selected the heat energy formula as ms delta theta. Heat energy formula as ms delta theta. Let us observe that phenomena now. So here what happened? Hot body lost heat, cold body. Now what we can write here? The cold body gained heat, hot body lost heat. Fine. The heat means we have to take Q. Q is equal to what we can write here? Mass M1 S1. For first hot body, what is the things provided there? Yes, observe carefully here. For hot body means M1 S1. Here T1 is high temperature, T is low temperature. So temperature difference when I am taking here, high temperature minus low temperature. Among T1 and T, no doubt T1 is high temperature. Because hot body and cold body contact, heat transfer from hot to cold and it loses some temperature. Already I told temperature decreased. That means T1 is high temperature, T is low temperature for first situation. So heat energy formula I can write now M1 S1 into T1 minus T. Now suppose if you observe for cold body if you observe, what is the phenomena we can observe? For cold body initially M2, next S2, then we got the temperature as T2, M2 S2 T2. Now temperature from T2 it was increased to T. So temperature has been increased from T to T. So there is increase in temperature. There is increase in temperature from what temperature to what temperature? T2 to T. So T is high temperature, T2 is low temperature. Because it's a cold body, it gains heat. By gaining heat, what will happen? Temperature increases. Temperature increases. So I am writing now the formula as M2 S2. Okay, what? Because I know the heat formula as Q is equal to ms delta T, ms delta theta or delta T. I can write anything, no problem. That is not an issue. Ms delta theta, or I can also write it as ms delta T, ms delta T. So anything we can use, no problem. So here what I am writing now, M2 is to S2. Here the high temperature is T and the low temperature is T2. So this is the formula for heat lost by hot body and heat gained by cold body. Then my formula is simply M1 S1 T1 minus T is equal to M2 S2 T minus T2. So always here what we have to take? Hot body minus cold body. Here also hot body minus cold body temperatures. So T1 is the hot body, because first what happened, initially it is T1, then it came to T, here temperature decrease. So I have written it as simply T1 minus T. But when in this situation what happened, from T2 to T it is increased. So increase it means what should I write? T is more than T2. As T is more than T2, I have written here it as T minus T2. T minus T2. So this is the formula what we noticed. I hope you are clear. Now the formula what I noticed here is M1S1 T1 minus T is equal to M2S2 T minus T2. So delta T is the temperature difference, like that we have written, and I want the T value, resultant temperature, M1S1 T1 minus M1S1 T is equal to M2S2 T minus M2S2 T2, M2S2 T2 I can write. Fine. Actually my target is resultant temperature T value I want. So I am sending this capital T this side and this term minus terms opposite sides I am taking, so that from that information I can write M1S1 T1 plus M2S2 T2. What happened here? Just I brought minus M2S2 T2 this side, it became plus M2S2 T2. Now this minus M1S1 T I will take other side. So this minus this side is there, means it will go other side, will become positive. So that what should I write now? Yes, M1S1 T plus M2S2 T, M2S2 T. Now observe carefully. Here in the second, that means in RHS side you can find M1, S1, M2, S2 are different and TT is same. So now if I take the T common here, I can take T common, I can write M1, S1 plus M2, S2 is equal to, here what I have, M1, S1, T1 plus M2, S2, T2. So finally, what is my formula? After this information, what should I write? Yes, T is equal to, I can write M1 S1 plus, T is equal to M1 S1 T1 plus M2 S2 T2 by M1 S1 plus M1 S1 plus M2 S2. This is the resultant temperature formula. I hope you are clear with how to handle the resultant temperature. So let us see what we discussed here. So two bodies of different temperature kept in contact. What happened? The two bodies that is having mass M1S1 T1 and other one as M2S2 T2. The two bodies, when they kept in contact, these two bodies kept in contact, what will happen when the two bodies kept in contact? They got, that is one is hot body I have taken, other one as cold body. Here I took the condition T1 as greater than T2, so heat lost by hot body and heat gained by cold body, and T is the resultant temperature. After this information I found M1 S1 T1 minus T is equal to M2 S2 T2 minus T, T minus T2, T minus T2. This is the formula I noticed, T minus T2. And also I noticed that T, from this information, above information I got, T is equal to M1 S1 T1 plus M2 S2 T2 by M1 S1 plus M2 S2. And one more point I want to remind you, these two formulas we observe now, fine. I want to remind you that here what happened means, the two bodies, let me take the body name as one is A and B. So now here A and B are in same state. A and B are in same state, changes their temperature. In same state, changes their temperature. So this is the phenomena we observed. Same state and temperature changes their temperature. Now the question is arised. Okay, this formula, okay, we are very clear. The two bodies kept in contact, then resultant temperature formula. When the two bodies in same state, they change the temperature. One is hot and other one is cold. One is hot body, no doubt, other one is cold body. So that T is called as a resultant temperature. And finally what happened? The formulae we observed related to resultant temperature. Fine, this phenomenon is over now. Now the question arises, if at all the two bodies we have taken in different states, what is the situation? For that, I want to take one example problem and explain this concept. You need to pay little more attention towards this one. Here you observe carefully now onwards. So what I am saying here is, I have taken one example now, that is 1 gram. I just have taken 1 gram of steam. Observe carefully, 1 gram of steam. Here this 1 gram of steam is mixed with 1 gram of ice. So what they mention here is 1 gram of steam is mixed with 1 gram of ice. Plus means here it indicates mix. So 1 gram of steam and 1 gram of ice mixed. So here you don't get worried. Steam means you have to take 100 degrees centigrade. Generally more than 100 degrees centigrade also steam will be there. But here in this question I am taking 100 degrees centigrade steam. And ice means here I am taking 0 degrees centigrade ice. I am taking 0 degrees centigrade ice. Ice can also have temperature less than 0 also ice can exist. But I am not discussing about that. I am discussing 0 degrees centigrade ice and 100 degrees centigrade steam. Both are mixed. Both are mixed. What will happen? No doubt steam means we can call it as hot body. And ice means what we can call it as cold body. Fine. Now what is the happen means what the things going to happen here? Hot body will loses heat energy. Cold body will gain heat energy. So here let us take one step here. What's the one step of coming down? Here it loses heat energy, right? So the heat energy lost, heat lost here. Here heat gain here. Heat gain and there heat is lost. So let me take one step. That is a 1 gram. That is a steam. 1 gram, okay. 1 gram is okay. Steam at 100 degrees centigrade to steam at, or otherwise directly without 1 gram I am writing now. Why 1 gram? We know 1 gram it is. Steam at 100 degrees centigrade to water at 100 degrees centigrade. Let us check it out. First we have to check it out. Steam at 100 degrees centigrade to water at 100 degrees centigrade. Suppose it has to convert. How much heat energy is required? How much heat energy is required to remove from the steam? Because here what happened? Initially it is steam. Now this will lose heat energy. It loses heat energy means it may first steam at 100 degrees cannot convert at water at 90 or anything. Steam will not exist below 100. Steam will not exist below 100. So it loses heat energy means steam has to convert to water by losing heat energy, right? Very simple. Here you observe hot body. Steam is hot body. It loses heat energy. It is already at 100 degrees centigrade. 100 degrees centigrade is the minimum temperature of steam. Yeah, below 100 steam will not exist. Below 100 will convert to what? Water. Below 100 steam will convert to water. Steam directly can't convert to 90 degrees water or 80 degrees water. Must and should convert to 100 degrees centigrade water only. 100 degrees centigrade water only. Fine. So now steam at 100 degrees centigrade to water at 100 degrees centigrade I want to convert. How many grams means? Okay, M1 gram. That is a known. Here they have given it is 1 gram. So what is the heat energy formula? Yes, heat energy formula is Q is equal to mLV. When should we use this formula? We have to use this formula if there is change of state. Change of state. So there is a change of state, no doubt. See here this is steam, this is steam. Now it's converted to water. Steam to water, change of state. So we have to use the formula mLV. We have only two formula, right? One is ms delta theta. Ms delta theta. When should we use ms delta theta? We have to use ms delta theta formula when there is temperature change in same state. Other one is ml. When should we use ml? That is, we have to use ml when same temperature change of state. Same temperature change of state. Now you observe here. So here what happens? Steam at 100 to water at 100. Change of state. So mLV. M we know that it is 1. LV value you have to remember. Every time they don't provide in the question you have to remember this. 540 calorie per gram. 540 calorie per gram. So this is 1 into 540. So I know that mass is how much? 1 gram into 540 calorie per gram. Gram cancel and I can write Q is equal to 540 calories. 540 calories. Suppose here I am checking it. Suppose steam is converting to, suppose steam at 100 degrees centigrade is converting to water at 100 degrees centigrade, because steam is hot body, no doubt it loses heat energy. Already is 100 degrees centigrade. When it loses heat energy, there is no option for steam, it has to convert to water at 100. First step. After water at 100, it can even decrease its temperature also, but okay, first we have checked this step, and here we understood that how much heat energy we have acquired, 540 calories. Now let us go for second thing. Ice, 1 gram of ice, 0. So now if at all this heat it gains heat, means what will happen? Ice initially at what temperature? 0 degrees centigrade. Now it can convert to what? Water at 0 degrees centigrade. We know this phenomena. Ice, what happened? From 0 degrees centigrade it convert to water at 0 degrees. So by taking some heat energy, ice maximum temperature is 0. If you give more heat for this ice, then what can happen? Ice can convert to water. Ice at 0 can convert to water at 0 only. So let us take now the step ice at 0 to water at 0. How much energy we are getting here? Here what formula I have to use? Ice at 0 to water at 0 means MLF. So nothing but M is here how much? Mass here ice also we have taken 1 gram. 1 into 80. So I can write simply here, because LF value, what is LF value? LF value is 80 calorie per gram. You have to remember those values, LF value and LV value. LF value is 80 calorie per gram. So I am writing here M into LF, that is nothing but 1 into 80. So here Q is equal to how much we got? 80 calories. So here once you just observe here how much heat is lost in just one process of converting steam to water at 100 means 540 calories. By taking here now ice, initially ice is at 0 degrees centigrade. If it is provided with 80 calories, it is converted to water at 0 degrees centigrade. Fine. So just by 80 calories, ice at 0 converted to water at 0. So here it is ready to give how much heat energy? 540 calories. But is the temperature is how much here for water? 100. But here water temperature 0. Did they came to equilibrium? No equilibrium condition, because steam 100 to water at 100. Here ice at 0 to water at 0 only, right? Water at 0 only. So now here water at 100 and water at 0, they are not in equilibrium. If they are not in equilibrium, we can go for another step for ice. Another step in this ice regarding. Let us check that one. So now this ice can go one more step. Let us check that. Ice can go for one more step. What is that? Ice at already converted to what happened? Ice at 0 degrees centigrade to water at 0 degrees centigrade. Just now we have written that information. There we notice the heat energy is how much? 80 calories. Now suppose water at 0 degrees centigrade to water at 100 degrees centigrade. Why you are taking till 100 degrees centigrade, sir? What is the use? Because already you observe here water is at 0, here water is at 100. They are not in equilibrium. If both the bodies acquire same temperature, then we can say they are in equilibrium. To get the equilibrium condition, for ice point of view, not steam, I am not touching the steam. Ice at 0 degrees, what is there? I am taking that information and I am going ahead here. So water at 0 to water at 100 means what we can write? Change of state. Remember, whenever there is a change of temperature, previously change of state, now change of temperature, no change of state, water, no change, temperature change, then heat energy formula is ms delta theta. Heat energy formula is ms delta theta. What is m? M is mass. They have given one. And here it is water, right? So specific heat of water is 1 calorie per gram per degree centigrade. So we know that specific heat of water as 1 calorie per gram degree centigrade. Calorie per gram degree centigrade. So temperature difference means what should I write? 0 to 100 means 100 minus 0. So here Q heat energy, let me call this as suppose Q1 and Q2. Here so 80 plus, here what we got here Q2, how much we got? Here Q2, let me take here Q2. So Q2 I am getting how much? Yes, 100 calories. I am getting it as 100 calories. We can note this one. 1 into 1 into 100 is nothing but 100 calories. Already I got here how much? 80 calories. So total heat gained by ice. Total heat gained by ice. How much here? Total heat gained by ice means what should I write here? Q is equal to 80 plus 100, 180 calories. So by just getting 180 calories, it is reaching the equilibrium temperature. It is reaching the equilibrium temperature. Let me write these steps at one place. So first steam, 1 gram, this is at 100 degrees centigrade. This is a 1 gram of steam is there. What we did here is we converted to water at 100 degrees centigrade. For this conversion, the heat provided is Q is equal to how much? 540 calories. But here same 1 gram, it also has to come to what temperature? 100. Remember, resultant temperature we have to get 100. So initially 1 gram ice at 0 degrees centigrade is given. So now I want to convert ice at 0 degrees centigrade to what should I convert? Water at 0 degrees centigrade. Ice at 0 degrees centigrade to water at 0 degrees centigrade. Here I got Q1 is equal to 80 calories. And next one more step is there. Water at 0 to water at 100 degrees centigrade. So here I got Q2 is equal to 100 calories. So what is the total heat? Total heat is equal to 80 plus 100. I wrote it as 180 calories. This is the information I provided. So but one thing you remember. Here 100 degrees centigrade temperature. Here also it reached how much temperature? 100 degrees centigrade. If they are in equilibrium, there is no further transaction. But to reach this ice from 0 to 100, from ice from where it is reaching from initially it is 0 to 100, how much energy required? Only 180 calories. If they are ready to give 540 also, we are not ready to take more. Actually what is the just think like that. We need 180 rupees and they are ready to give 540. Why we will take more? We need 180 to become equal with them, so we will take only 180. Even they provide 540, we don't care. That means you have to understand that is 1 gram of ice at 0 degrees centigrade to reach 100 degrees centigrade water, the energy required is only 180 calories. If total steam at 100, that is 1 gram of total steam at 100 degrees centigrade converted to water at 100 degrees centigrade, what will happen? They will provide 540 calories. But we require how much? Only 180. When the temperatures became same, we require only 180. So we don't want 540. Our target is we don't want their 540. We want only 180. Our target is not 540. So then what is our target? Our target is only 180 calories. So let me write here instead of this one. Actually what is the formula I wrote? Q is equal to mLV. Let us take total mass is not converting. Some X mass is converting. Into water. Not total mass. From 1 gram of steam at 100 degrees centigrade, how much is converting? X grams of water. It is converting into X grams. Sorry, not X grams of water. Here what happened? Observe carefully, very dangerous it is. So here what happened? 1 gram of what I have taken here? Steam at 100 degrees centigrade. In that, only from out of 1 gram, only X grams of steam, only converting to water, only X grams of steam is converting to water. So let me write now X into 540. We have to find this X value. So here this X into 540 must be equal to how much? 180 calories. That means what I understood is to just convert ice at 0 degrees, 1 gram of ice at 0 to water at 100 degrees centigrade, we don't require total 540 calories. Even less than that is also sufficient. How much less than that means? 180 calories only we require. So we no need to convert total 1 gram steam. Total 1 gram steam not required to convert. No need to convert total 1 gram steam. Just if you convert X grams of steam, it is enough. So now the mass I have selected as only X grams I am converting. X into 540. So we know that heat lost by hot body is equal to, from method of mixtures, what we know? Method of mixtures, what we know? Yes, heat lost by steam. Heat lost by steam is equal to heat gained by ice. Once they got in equilibrium temperature, we must not do further transaction. So when they reached the equilibrium temperature, that is 100 degrees. So we got here how much? 180. Here we told some X grams is converted is enough. No need to convert total. X by 540. So now X is equal to 540, right? 540. X is equal to 180 by 540. That is nothing but 1 by 3. So just what they are saying that now, if 1 by 3 gram of ice, 1 by 3 gram of ice is, sorry, 1 by 3 gram of not ice, no, what is that 1 by 3 gram? Yes, 1 by 3 gram is X value we got. X value what we got here? 1 by 3. Observe carefully. X value we got 1 by 3. So 1 by 3 X is related to what? Steam. Now X 1 by 3rd gram of steam. If suppose 1 by 3rd gram of steam at 100 degrees centigrade, is converted, then 1 gram of ice, rises its temperature. 1 gram of ice, first what will happen? 2 steps here. 1 gram of ice converts to what temperature? Ice 0 degrees. 1 gram of ice at 0 degrees converts to water at 0 degrees centigrade, and also rises to how much temperature? Rises to 100 degrees centigrade temperature, and now this is the condition of thermal equilibrium. They got same temperature. What is the resultant temperature? Now the points. First point, what is the resultant temperature? Both the bodies acquired, what is the resultant temperature? Means both the bodies acquired 100 degrees centigrade. How much mass of steam condensed? Mass of steam condensed. How much mass of steam condensed? 1/3 gram of steam condensed. That means 1/3 mass of steam has been converted. Observe carefully here what I told. 1/3 gram of steam at 100 degrees centigrade is converted to what? Yes, it is converted to how what? It is converted to water at 100 degrees centigrade. Water at 100 degrees centigrade. That is nothing but condensation. So we can call it as 1 mass of steam condensed is 1/3 gram. So mass of steam left uncondensed. Mass of steam left uncondensed, they are asking. Left uncondensed. Total mass of steam is how much? 1 gram. In that 1 gram, 1/3 is condensed. That means how much is left uncondensed? 2/3 gram of steam left uncondensed. 2/3 gram of steam left uncondensed. So, out of 1 gram of steam, so this is the phenomena whenever they mention 1 gram of steam at 100 degrees centigrade, 100 degrees centigrade is mixed with what? 0 degrees centigrade ice at ice of 1 gram. This also how much we are taking? 1 gram. So whenever there is a mix of 1 gram of steam at 100 degrees centigrade with 0 degrees centigrade ice of 1 gram, then what will happen? Resultant temperature is 100. Mass of steam condensed is 1/3 gram. Mass of steam left uncondensed is 2/3 gram. Now one person asks, what is the resultant temperature? What is the resultant temperature? Means 100, okay. Steam condensed 1/3 gram, okay. Steam left uncondensed 2/3 gram, okay. Now the question is total water at resultant temperature. Total water at resultant temperature. Observe carefully what I am doing now. Total water at resultant temperature. Total water means how much water? Here how much steam is condensed? Steam is condensed is 1/3 gram of steam is condensed. Condensed means steam converted to water. So 1/3 plus. Now how much ice has been converted to water? Total 1 gram of ice is converted to water. So 1/3 plus 1, because here 1/3 is steam converted water. 1/3 is what? Steam converted water, and 1 gram is ice converted water. So 1/3 is steam converted water and 1 is ice converted water. Total is 1/3 plus 1 is 4/3. So finally 4/3 grams of water is left at resultant temperature. At resultant temperature at 100 degrees centigrade, the resultant water in that one is 1/3 plus 1, that is 4/3 grams. 4/3 grams. I hope you are clear now. So what I did here, please observe carefully here. The question, what they have given question here, this is the last question, is very important. Just they told that 1/3. What is the question? Oh no, this is not a question, right? We'll go back 1 minute. Here, this is here. So what happened? Ice at 0 degrees centigrade. Ice at 0 degrees centigrade. How much mass? 1 gram is mixed with 1 gram of steam. 1 gram of steam. Steam is at 100 degrees centigrade. First, what we did means we just check how much heat lost by hot body in one step. One step means steam at 100 to losing heat means steam at 100 will convert to what? Water at 100. So formula is conversion of state MLV, 1 into 540 calories. And then we check for ice. Ice initially 1 gram. So what happened? Ice at 0 to water at 0. It is gaining heat because what are the lost heat? By taking that it can gain to water at 0. First step. So ice at 0 to water at 0, how much energy? 80 calories. Fine, we are happy with that one. We got 80 calories. Next step we want. Now already it became water at 0. So water at 0 to water at 100, how much? Again, because water at 0 to water at 100 means same state temperature is changing. So now I selected Q2 equal to MSW delta theta. SW value is 1 calorie per gram per degree centigrade. Mass is 1 gram. Temperature difference 100 minus 0. I got 100 calories. Now ice at 0 to bring water at 100. Ice from 0 degrees to water at 100 degrees centigrade. I want to bring that temperature means how much total heat required? 180 calories. 180 calories. Once they reach 100 degrees centigrade means already what happened in previous condition, steam reached 100, steam at 100 reached to water at 100. Now we are able to make ice at 0 to water at 100 by providing 180. The problem occurs, they are ready to give 540, but we require only 180 to reach them same temperature, to reach their same temperature. See, water at 100, now to reach at 100 degrees centigrade, how much heat energy is required? Only 180. But there, according to them, their conversion they will provide 540. No, we don't want. That means we don't want means no need of total steam to be converted. You have to understand this point. No need of total steam to be converted to water. If total steam is converted to water, the heat we are losing is more than what it is gaining to required same temperature. It must not happen like that. So once the got equilibrium temperature, no transaction. So no need of total steam to convert. Let us take some x grams of steam condensed, x grams of steam condensed, only x into 540. So this heat lost, x into 540 is equal to heat gained 180. So I equated that, x into 540 equal to 180, I got x equal to 1/3 gram. What does it mean? If 1/3 gram of steam at 100 degrees centigrade is converted, then 1 gram of ice at 0 degrees centigrade converts to water at 0 and also rises to 100 degrees centigrade temperature, and they becomes thermal equilibrium, same temperature. So here 1 gram of steam at 100 degrees centigrade when mixed with 0 degrees centigrade ice of 1 gram, resultant temperature is 100, steam condensed is 1/3 gram. They told steam condensed 1/3. Initial mass is how much for steam? 1 gram. In 1 gram 1/3 is condensed means. Condensed means what do you mean by condensed? 1/3 of steam converted to 1/3 gram of water. So how much mass of steam left uncondensed means 1 minus 1/3. 1 minus 1/3 is nothing but 2/3 gram. Total water resultant temperature. What is total water resultant temperature? Already out of 1 gram steam it became 1/3 gram, it became water. Out of 1 gram steam 1/3 gram of steam converted to water. Already this ice at 1 gram of 0 degrees converted to 100 degrees centigrade water. So total 1 gram is converted for ice, total 1 gram converted to water, steam 1/3 gram converted to water. So 1/3 plus 1 is nothing but 4/3. 4/3 gram of water is left at resultant temperature. So why I specified this topic means here there are two different states. They are in the two different states and they combine. This is the situation what we discussed now is two different states and combine. One is steam, other one ice. Then we can't apply this resultant formula as T is equal to M1S1 T1. This formula we can't apply it. This formula is applicable only when the two bodies are in the same state, their temperatures are changing. The two bodies are in either two are liquids or two are solids, like that they have given. Then we can use this formula. This one and this one we can use. But here it is not like that. In this regard, we have to calculate these conversions. I hope you are clear with this today's class, and just to go through these things, and in next video I will explain more problems, so you will be having more clarity in this topic. Thank you.